I'm going to attempt to fit on this one piece of paper all these 7 things about this quadratic equation. The vertex, the x and y intercepts, whether it has a maximum or minimum and what that is, the domain and range, the axis of symmetry, and then I'll draw a little sketch. So, first, to find the vertex, we start with the x value of the vertex. Easy way to get that is take the opposite of b over 2a. b here is a positive 20, so the opposite would be negative 20. 2 times a, that would be 2 times 5, which is 10. So the x value of the vertex is a negative 2. Now I need the y value of the vertex, so I find f of the x value. I find f of negative 2. That'll be 5 times negative 2 squared plus 20 times negative 2 plus 15. Okay, so that's 5 times a positive 4. That would make that 20. And 20 times negative 2, negative 40 plus 15. And if we add all this up, that's negative 20 plus 15 comes out to negative 5. So the vertex is right here. Now I want x-intercepts. Remember, x-intercepts, I'll be making the sketch over here later, x-intercepts are points where the graph touches or goes through the x-axis, and so those points have a y value of 0. That means we can replace the y, or the f of x, with a 0, and then figure out what x values make the y value come out to 0. So we're just solving this for x now. I don't have to preserve these a, b, and c values. I'm just solving for x. So I can divide both sides of this by 5. Notice everything is divisible by 5. And then I get x squared plus 4x plus 3. And this factors pretty nicely and easily. I can factor that into x plus 1, x plus 3. So what x values will make this true? A negative 1 or a negative 3. So the x-intercepts will be at negative 1, 0, and also at negative 3, 0. For the y-intercept, we just calculate f of 0. And if you plug in a 0, you're going to have 0. If you plug in a 0 for x, you're going to have 0 plus 15. And I think we said in lecture, the y-intercept is always the c number when the equation's in standard form. So y-intercept is the point 0, 15. What's next on the list? Does this have a maximum or a minimum, and then what is it? Well, since the a number is positive, the graph is going to open upwards. That tells us there'll be a point where the y value is lower than all the other y values, which we would call a minimum. And of course, the minimum happens at the vertex. We figured out that was negative 2, negative 5. We're going to say the minimum is negative 5 at x equals negative 2. What is the minimum? It's the y value. Where is the minimum? You tell where you get the minimum by saying what that x value is that you used. Domain and range. Look at this little sloppy picture. For the domain, again, for any quadratic, it goes forever to the left, forever to the right. It doesn't skip anything. So the domain is negative to positive infinity. The range, the report of what y values do we get, well, it goes up forever, but it never goes below negative 5. So the range is negative 5 to infinity. And then the axis of symmetry, that invisible line down the middle, that vertical line, has an equation. X equals, what's the x value always here? It's always the same as it is in the vertex. X equals negative 2. And then for the sketch, let me do a better sketch over here. We had a vertex at -2, -5. We had x-intercepts at -1 and -1, 2, 3 at -3, and a y-intercept at 0, 15, which would be way the heck up here somewhere. And so even with this sloppy picture, boy is it ever sloppy, you do see we get a very skinny upward opening parabola. It's very skinny because we had a relatively large A value with the minimum right there, and it all fits together like a nice puzzle.